Hello, welcome to this meeting and thank you for giving us this opportunity to present furnace improvement services. This is my baby. I started this company 27 years ago and today we will talk about our capabilities. It's been a wonderful team effort and I want to start by thanking all the team members who have contributed to the growth of furnace improvements. Furnace improvements was started in 1996 and our focus has been improving the capacity of furnaces, improving the run length, maximizing efficiency and maximizing profits for end users. So I want to talk to you about how and why I started this company. I moved to US in 1990 and I worked in a heater company for about 6 years. So around 1994, we were going around in Texas City with one of my sales managers. And Texas City has almost 3 refineries located and you can see many stacks. And I asked curiously my sales manager Bob, "Hey Bob, who takes care of these furnaces?" And he said, "No one." I said, "Why?" He said, "It's a very difficult business and everybody is focused on supplying new heaters." So I had this discussion and I forgot, but a couple of years later, there was a reorganization in that company and I got an opportunity to start something new or start a new innings. And I thought, why not I take this challenge and start working with end users on improving their furnaces. So March of 1996, I started this company from the 4th bedroom of my house in Sugar Land, Texas. And slowly we grew, and 2005 we started an office in India, initially in Kalkaji, New Delhi, and for the last 6 years we have been in Noida office in India. This is our main office now. 2014 we established a CFD office in Pune. Most of the CFD engineers live in Pune because of plenty of opportunities, so we started an office there. And last year we merged it with our Noida office because we realized CFD engineers and process engineers need to have better interaction. So now that office has been moved to Noida also. Our work is mostly working with end users and mission is to improve the performance of existing fired heaters. We try to provide unique value added solutions, and I'll tell you in a little bit that we have a contrarian approach for solving problems. So we always are looking for something new. We always try to see how we can do it. We try to do very high quality technical work. We are working around the clock because of time difference between US and Indian office, and we are able to keep schedules. We have supplied a heater in 6 months to a client in Latin America. They forgot to order a small whisk breaker furnace and they were looking all over US to find a supplier who could do it, and ultimately they came to us and we did that in about 6 months time. And the reason is because we are very small, nimble and efficient. We also do our own fabrication drawings, so we don't have to depend on third party. And our motto has been do it once, do it right, because that's the most economical way of executing projects or solving problems. So that's what we have done. Uh, I've been very fortunate to have a very good team of engineers, and most of our people are in Noida now. In the US, we mostly have project management team and accounts team, and we do take help of contractors for some of the disciplines where we don't have continuous requirement. The difference between our company and other heater companies is we are focused on process. We are focused on troubleshooting, solving problems, improving efficiency, improving capacity. So we have a very strong process group. We currently have 8 process engineers, and most of the time, most heater companies will have 1 process engineers and 8 mechanical engineers, because they are doing new furnaces, so designing a furnace does not take that much time. So 1 process engineer can feed 8 mechanical engineers, whereas in our case it's 8 process engineers who are working and trying to develop new solutions, trying to understand furnace operations and analyze it. So that's the difference between our company and the other companies. Most of the people think that we are consulting company, but we used to be a consulting company, or in fact we started doing training of engineers and operators for the first 3 years. That's what we were doing, actually, going from refinery to refinery and doing training of operators, doing training of engineers, teaching them how to operate furnaces. We did 26 courses for Lyondell Citgo in Houston. Today, or actually for the past 15 years, we are a full service heater company. We undertake complete turnkey projects. We can even undertake erection. So we start with the process. We have our own CFD modeling group. Then we have a mechanical and structural group. We do all our own drawings. As I said, we also do our fabrication drawings. We also have a 3D modeling group which model the furnaces using SolidWorks. So that way all the fabrication drawings are generated by this 3D programming. So we can undertake any project and execute it. In fact, you want the process design from us, we can get you the process design. You want process design and engineering, we can do process design and engineering. You want us to include supply, we can include the supply also. So that's our model is very, very flexible. Our focus has been on refinery heaters and boilers. We have worked on a number of crude heaters, vacuum heaters, hydrotreaters, reformers, catalytic reformer furnaces, coker heaters, hot oil heaters, CO boilers, waste heat boilers. We have done a number of ultra low NOx burner revamps, and we have also installed a SCR unit on one of the largest crude heaters in the US, almost 800 million BTU furnace. Our clients want to take this opportunity to thank all the clients who have trusted furnace improvements, and we want to thank them for all the business what they have given us. We are a very small company, so most of the business which we get is through word of mouth, or people reading our presentations, people attending our conferences. That's how we get business. One of the biggest clients for the past 15 years has been Phillips 66. We have a master service agreement with them, and we have been revamping and even supplying new heaters to them for a long time. There are other clients like Countrymark, Citgo, Delec, Valero, who have been giving us business for a long time now, and we have whatever trust they gave to us, we have reposed it pretty nicely. So every client is important to us, no matter how small or how big is a client. I talked about the contrarian approach, and as a result of the contrarian approach, we have been able to develop 3 technologies which are patented now, and we will talk a little bit more about them, but necessity is the mother of invention. So all these technologies were developed when we saw the need for them, and we will talk in detail about this. And all these technologies are very, very simple. There is no complicated technology. It's all simple technology to improve the performance of furnaces. Let's talk about the split flow technology. And split flow technology, we developed it in the year of 2000. 2000 is when we developed it. We had a client who had a catalytic reformer heater, and he was looking for improving the efficiency of that furnace. The stack temperature was 1100 degrees F. They did not want to generate steam, they did not want air preheating, so the only option left for the engineers was to preheat the feed. So they first went to the OEM. The OEM gave them a conventional feed preheating arrangement, and that project was costing about $6 million. So Citgo, who happened to be the client in this case, came to us and said, this is the report submitted by the OEM. Please see if you can lower the cost, if you can develop an alternate scheme. And that is where we came up with the concept of split flow. So in the split flow, as you are aware, in a conventional heater, the passes are in series. Like the feed is divided into 2 or 4 or 6 or 8 passes, and they all passes go into the convection section, then they go to the radiant section, and then they meet, then they are combined again and goes to the transfer line, and from transfer line they go to the reactor or distillation column. And most of the time you are looking for increasing the capacity anywhere between 10% to 25%. So what we do is we leave the radiant section as it is, we do some surgery in the convection section, and we take the extra feed, preheat it up to the same temperature, and it doesn't go into the radiant section. We preheat it up all the way to the outlet temperature, what would be coming from the radiant section, and then mix it after all the passes. So that's a very simple concept, or you can say a 4-pass heater is converted into a 5-pass heater. The second technology what we came up was again from a client's perspective. We had a client, Valero in this case. They had a crude heater. They wanted to increase the capacity of that heater by 50%. And everybody had told them that it is not possible. So they said, okay, let's put a new heater. But when they started looking for the space, they could not find space for putting a new crude and new vacuum heater. So space was very tight, and also if they put a new crude and vacuum heater, they had to hire 2 operators. So that would have been added cost. So they came to us and said, hey, you can have this project if you can increase the capacity of my furnace by 50%. We looked at it, we did here, there, and then we said, okay, let us come up with this concept that we put the burners at about 5 to 7 degree angle to eliminate flame impingement. And that's what it is. Most of the time, the furnaces have high tube metal temperature problems, and we are solving it by inclining the burners towards the tube center of the heater. And what it does is, the concept is very simple. it keeps on increasing the distance between the flame and the tube, or burner and the tube. And generally, as you all know, the burner, the flame tip is one of the hottest points where the combustion gets completed. And by the time, if the flame is 20 foot height, we are able to get another 2 feet clearance, which is very substantial, especially in BC heaters, which are designed very tightly and have ultra low NOx burners. That's what we can get by using this technology. So very simple concept, and we will talk more about this. Some of the benefits what we have seen is improved flame pattern. We have installed it in 2 crude heaters, and in both cases the run length improved from 1 year to 5 years. That's how much improvement the clients have seen. Better flue gas recirculation patterns, uniform tube metal temperatures, no hot spots, increased heater run length, longer tube life, and reduced coking rate. So everything, basically just by putting the burners at an angle, we have been able to reap a number of benefits. So this is a heater at Corpus Christi. This was a very large twin vertical cell heater, and they had 2 tube ruptures in 3 years, around I think 2010 I believe. And they came to us and said, what can we do? And I said, we can do a lot of things, but the first thing what let us do is put your burners at an angle. So they were not convinced initially, and our team did CFD for almost 6 months to convince the client, convince the EPC, and once they were convinced, we installed it, and there was no looking back. We use their existing burners, and this is the CFD model. You can see the flue gas velocity vectors, that when they were having vertical firing, they had this internal recirculation pattern taking place, pushing the flames towards the tubes. And when we did put it at an angle, this recirculation pattern disappeared, and the flames were away from the tubes. We also looked at the flue gas temperature contours. You can see very high concentration of hot flue gases near the tubes over here in this area, and that's where the tube rupture had happened. And by the time we put it like this, the tubes were much cooler. Actually, there was no concentration of hot flue gases near the tubes. You can see the flue gas temperature contour in the plan view. You can see the flames, hot gases are almost everywhere, almost 2200 degrees F. And here they are concentrated in the center, and this furnace was very unique. Instead of being a cylindrical furnace, the original designer made it in an octagonal shape, and I think maybe because of fabrication, ease in fabrication, that's why they made it like that. Then we also looked at the mass fraction of CO. Typically 2000 ppm and above, we consider it a flame as per the international practice. And this is how you see there were flames all over the tubes. And when you put it in the inclined it, where the flames were restricted within the burners only, In this case, the flame was going into the tubes, and in our case, the flame is away from the tube. So it was a very significant difference. The flame did become a little longer by about 10%, but we had a lot of benefit. The tube metal temperature, even though the CFD predicted about 100 degrees Fahrenheit reduction or 55 degrees centigrade reduction, we were able to see almost 200 degrees F reduction in real life. And you can see here the hot flue gas is high tube metal temperatures, and here it is very uniform, flue gas temperature. Since then, we have made it a standard to install inclined firing technology in all our new heaters. We have done it, and we have also done, so there are about 12 heaters where we have installed it, and it's been a big success. And if you are having any flame impingement problems, high tube metal temperature problems, please talk to us and we can help you at a very, very low cost. Another technology which we developed is, this is our latest patent or invention, smart stack dampers. What we were finding was most of the heaters suffer from excessive draft, and draft is one parameter which is least understood. Everybody understands O2 because O2 has a very nice expensive meter, but very few people understand draft. So we realized the heaters are not able to operate on low excess air or not efficiently because the existing stack dampers are not working. And our analysis of almost 40 or 50 heaters was that the stack dampers are grossly oversized and therefore they are ineffective for control. So we decided, we thought about it and came up with the concept of smart stack damper, where we, instead of putting one pneumatic actuator, we will put two actuators, and that way we are able to change the CV, the control valve coefficient, and get the damper back into the control range. So the control becomes a lot more effective, and we are also installing this technology. So whether you have a parallel blade damper or an opposed blade damper, we can convert your existing dampers to smart dampers. We can make them smart. The cost is very minimal, and we can reuse a lot of your existing parts also. So the best advantage is that you get a better controlling characteristics. And when we talk about control, all dampers need to be controlled at least twice, because the draft depends on ambient temperature, and between day and night you can have about 15, 20, 30 degree Fahrenheit difference. And so you do need to control draft at least twice a day, if not more. So the smart stack damper solves that problem. It gives you efficient control, it gives you savings, fuel savings, and payback time is in weeks actually. Very, very fast. I want to talk to you about some of the projects which we have done. As I was talking about this platform or heater capacity improvement, this was a project, this was one of our first projects. We did it in 2001, and we saved our client $3 million, and that is how we patented the split flow technology. This was a case where we reduced even NOx also. Excuse me. The stack temperature, as I said, was 1100 degrees, and we reduced it to almost like 480. So 20% improvement in efficiency, over 20%. And the client saved almost $6 million. So the payout time was less than 6 months on this project, So this is the heater before the revamp, and this is the heater after the revamp. And you can see we not only did the split flow, we fixed their stacks, put ladders and platforms, upgraded the damper. So we did whatever we could do within the budget, we were able to do it for that. We, as I said, we have worked on one of the largest heater in US. This is almost 750 million BTU, and we installed the SCR unit. Not only we installed the SCR unit, we added a new waste heat recovery, modified ID and FD fans, and while we were doing this, we improved the efficiency by 3.5%. Efficiency improvement was not in the project scope, but we saw an opportunity and we told the client that we can improve the efficiency by a very minimal investment. So we did that, and we were able to save about $5 million as a result of this scheme. The total project cost was $26 million. We could do it in about $21 million. On the left side, you will see a conventional SCR system. This was the original heater, and we would have put a waste heat recovery SCR and then took it back by putting an additional fan, because SCR needs a temperature window, so you had to remove the surface. The stack temperature was 400 degrees and SCR works at 650, so you need to get down to 650 degrees, so you have to remove that surface and then relocate it in the waste heat recovery. What we did was, whenever we removed that surface, we used that surface to have the duct and waste heat recovery and SCR. We did that, So as a result, no ID fan was needed, smaller flue gas ducts, and no stack modification. So we saved a big bunch of $5 million for our client. This is another project we did for one of our clients. This was a very challenging project actually. The project was awarded to an EPC and burner manufacturer. They had started working on it, and midway through that project they came to us and said, we cannot execute this project, you execute this project for us in about, I think there were only about 10 or 11 months left actually. And the project was converting the CO boiler to a natural gas boiler. But the challenge was that EP had said you can do it, but the NOx has to be less than 15 ppm. And 15 ppm was not possible just by doing burners. So we came up with the concept of new burners along with FGR and steam injection, And again, while we were doing this project, we saw that we can improve the economizer design and get our client another 4% thermal efficiency on that boiler. So we saved almost $6 to $8 million for our client on this CO boiler. If you have any issues with any of your boilers, CO boilers, please let us know. We have the capability of modeling boilers better than boiler vendors themselves, so we can really help you if you have any issues in your boilers, CO boilers. This is another heater we did, reactor charge heater revamp. The client wanted to minimize the pressure drop, so the 8-pass heater was converted into 4 passes, and the tube size was increased from 4 inches to 8 inches. We did relocate the burners and to eliminate the flame impingement, and also added a new tight shut-off damper for this heater. This is a project we did for one of the refineries in Texas, and this refinery started processing shale crude, and when they started processing shale crude, their crude heater run length came down to 3 months. I think they were getting 3 or 4 years before, and once they put shale crude, they started decoking the heater 3 months. So then they went to an anti-foulant company, and the client was giving the vendor started supplying anti-foulant, and it did improve it a little bit, but it was costing them a lot, like almost like $5 to $6 million. So they came to us and said, we need some help, and we said, okay, we can help you. We looked at it, we did CFD, and we said the burners are the culprit, let us change your burners. So we took their existing burners, put new low NOx burners, reduced the flame length, reduced tube metal temperatures and run length. Even though they told us we will be happy if you can double the run length from 3 months to 6 months, we increased the run length by about 6 times. So from 3 months it went to about 18 months, or I think even higher actually. So this was a very, very successful project. This is a CFD. You can see the existing burners had very large flames, and the burners which we put later on had very short uniform flames. So we do a lot of extensive analysis. This is another client of us for which we have been working for about 15 years in their refinery. They had a DHT heater. The capacity was 14 million BTUs, and they wanted to increase it to 22 million, 22 and a half. So they said, can you increase the capacity by 60%? As we looked at it and we said, yes, we can do it. So we took their heater and extended the radiant section, put a new convection section, put a new stack, and added a burner, and put those burners at an inclined firing technology, and it worked out a big success. So this is the existing heater, you can see, and their flue gas temperature was 847. We reduced it to 773. From 3 burners we went to 4 burners at an angle, and a new convection section at stack. So now they are asking us to look at the heater right next to it. This is another crude heater which I told you when we were talking about our inclined firing technology, and this was having lot of issues, and we just by putting burners at an angle, new burners, we were able to reduce the tube metal temperatures, give them higher capacity on natural draft, and also improve their run length from 1 year to 5 years. So this was their existing heater, vertical cylindrical heater, 8-pass heater, and they had 12 burners, and we put the new burners like this, and the project was a big success. This is another very large crude heater in one of the refineries, a twin cell box heater. The client was facing capacity limitations. The heater was air limited, and the flue gas temperature was also pretty high at about 600 degrees. So we gave them a new convection section, new wider convection section, new optics, and a new stack, and we improved their efficiency capacity substantially. The client has been very, very happy. You can see the size of the convection section, what they had before, and what we were able to put in the revamp. It was almost 4 times the convection section. The stack temperature is down to 373, almost like 250 degree reduction. You were able to achieve. This is, we have worked on coker heaters also. This was a coker heater air preheater upgrade. So the client was having issues like the air preheater was corroded, high flue gas delta P. They were running heaters on natural draft. So we gave them a new air preheater, new ID fan, new FD fan, and reduced their flue gas temperature to 300 degrees. This is the 3D model our team has prepared. So you can see this is a new plate APH. We added a new steam APH, new ducting, new ID fan, new FD fan. So we were able to improve their air preheating system substantially. This is another job we done for the same client. They were going to retube their coker heater. So we told them, hey, before you retube, why don't we do the improvement? Because most of the time the clients are retubing in kind actually. They don't take the time or hassle to do any improvement. But we put our foot in the door and told them we can help you, and we were able to make several improvements in their radiant tube layout. They were having a pass imbalance, like the outer passes were being fired 30% harder as compared to the inner passes. We were able to fix that. They were having flame impingement on these roof tubes. We moved these roof tubes away. So we were able to improve their performance significantly, by making some small improvements. And you can see this is their CFD modeling, and that's where the hot flue gases and hot tube metal temperatures were occurring. And once we moved the tubes on the roof, the high tube metal temperatures went away actually. So we have several references of split flow. This is another heater where we have, this is a very interesting case actually. The client wanted to increase the capacity by 23% and reduce the pressure drop also. So they looked at the heater, they talked to the EPC. EPC said, hey, we cannot do it, it's better to go for a new heater, and they were almost going to order a new heater for $6 million. They contacted us and we looked at the heater and we said, hey, we can use our split flow technology and we can do this job for less than $1 million. So we got that job, we got that project, and we replaced a new convection section and converted the heater from 2 pass in the process to 3 pass. Like we put 1 pass in the convection section and put the steam recovery or waste heat recovery section downstream of this pass, and by doing this we were able to reduce the pressure drop, increase the firing, and limit the firing also. So we did that project. So this is another project we did for one of our clients where we not only did NOx reduction, we increased the capacity and we did pressure drop reduction. So in these heaters we implemented 2 of our technologies. We implemented split flow technology to reduce pressure drop, and we also implemented our inclined firing technology to increase the capacity of the furnace. So these are very, very successful heaters, have been running for almost like 10-11 years now. This is the old convection section, this is the new convection section, and we inclined the burners by about 7.5 degrees. We have done work for another client where we put split flow in vertical cylindrical platformer heaters, and we were able to increase the capacity from 30,000 barrels to 40,000 barrels per day. We were able to do that. It worked out good. Most of the time we attack convection sections because convection sections are very easily fabricated in shops and can be installed. So you can see the convection section before revamp and after revamp. So that's where we are able to get more capacity, higher efficiency. We have also supplied a number of new heaters. It's not only that we do work on revamping, we work on new heaters also. So we have, I think, done about 12 or 14 new heaters. This is our star new heater which we have supplied to a refinery in Louisiana, a chemical plant in Louisiana, and the plant was very tight on space, so we came up with a novel design of split stream air preheater, and we put an SCR and ID fan on top of the convection section. So very innovative design and has been running successfully for about last 5 years now. We have done process design of crude and vacuum heaters with 8-year run length, and we proved it actually because this heater was started in 2001 and have been able to run it for 8 years non-stop. They came to us, and recently last year they came to us and we designed 2 other heaters, crude heaters, for 8 years run length. Unfortunately, the project did not go through. We have worked on CO heater revamps also. We have also worked several projects in India. We have some agreement with BHEL, and we supplied a design and engineering service for a fired heater at IOCL Panipat. This was what I was talking about, supplying design for 2 new crude heaters for Lake Charles. So thank you very much for giving a patient hearing, and what we want to request you is, if you have any heater which has been giving you problems, try us out and we will do our best to make it the best heater. Thank you very much. Bye.